Hello, Mrs Nick Taggart here. In this video, we are looking at lesson 2 of National 5 Arcs and Sectors. We are going to be working out the area of a sector in this one. Now, I've already done these videos before using the formula in a slightly different way, but I've decided to start teaching using this triple formula method. After seeing a recent exam paper, this seems to actually help a little bit for certain candidates. So we're going to give this a try. Quick reminder, if you haven't seen video 1, we talked about minor and major sectors. Minor is the little part of the circle, major is the big Pac-Man part of it, so the big white one in this. Be careful what angles you're using. I did an example in a previous video where I asked for the minor, but I gave you the major angle, and you'll maybe see some of them when you come to do past papers. So just watch your angles on those ones. And this was a formula what we're using. It looks a wee bit like the sine rule, but remember in sine rule you only ever use 2 parts and 2 parts. So because I'm looking at area here, I am not working on the arc bit. Now, to explain a wee bit where the formula comes from, it is literally, it's a regurgitation of your area equals pi r squared formula. And sometimes if you maybe had to find the area of a half circle, you might have said area equals pi r squared and then divided it by 2. But that dividing by 2 is the same as maybe timesing by a half, because it was a half circle. That half circle comes from maybe 180 degrees out of 360. And all I've done is I've moved that pi r squared underneath the area. But you don't need to fret too much about it. 3 words in your formula: arc, area, angle. Formula for arc underneath, formula for area underneath, and 360 under the angle. So let's go see it in action. So here's my first question. I am looking for the area of this sector, so I'm not using the arc part of the formula today. So I'm going to area equals, my angle is 280, my pi r squared, well this is my radius of 25, so I've got pi times 25 squared under the area, and I have 360 under my angle. But like in sine rule, you want rid of this thing down here, so it cross multiplies and comes over to the other side. So we have area equals 280 over 360 times pi times 25 squared. Now at this stage we should be using the pi button. If you aren't using the pi button, please feel free to use 3.14, but make your marker's life easier and actually write 3.14. Don't write pi and then use the pi button and confuse us. It might cost you marks if someone's doing a quick glance at it and not marking correctly. So anyway, pi button. Typing that in, I get 1527.163. I like to 2 decimal places, so we're going to take that back to 16. And don't forget your units. There's always one question in your exam. This is an area question, so it's not centimetres anymore. It's centimetres squared. And I'm just doing it to 2 decimal places. But yeah, one question in your exam somewhere, you will get marked down if you don't put your units. So please always look for that, particularly if you're going through at the end of the exam with time to spare to check your work in. This one's a bit tricky because I need to do a bit of work first of all to get my angle, don't I? There isn't an angle in the centre there. Now if you're clever, you might know straight by looking what a fifth of a circle is as an angle. If not, you go to your calculator and you do 360 divided by, I was going to write 12 there, divided by 5, and you get 72. So the angle at the centre is 72. It's handy to know that because it could save you having to simplify 72 over 360 in a non-calculator paper. But anyway, it's 72, my radius is 12, I'm good to go to the formula. This is quite common to get an extra mark in to start a question. I talked about sometimes they'll do it with a Ferris wheel where it's maybe divided into 10 and you would divide by 10 to get the middle angle, etc. Or they talk about a clock going round where you start by dividing by 12. Anyway, let's go to my example. We are not using the arc part of the formula, so we're going straight to area. So we have area over pi r squared. My radius is 12. It's not written the biggest there, but it is 12. So I've got pi times 12 squared equals my angle of 72 over 360. This pi times 12 is going to get cross multiplied over to here. So we have area equals 72 over 360 times pi times 12 squared, which is 90.477. So to 2 decimal places, that will become 48 centimetres squared. Again, don't forget your units. As always, where possible, I like to show you a non-calculator question. So this one is non-calculator. So again, I'm not using the arc part, I'm using the area formula. In this case, when it's non-calculator, it always reminds you to take pi as 3.14. There was one question years and years ago where they made you keep it as a symbol, but it's only been asked once. So we're going to go for area over pi r squared. So our area, our radius is 20, so it's pi times 20 squared. Our angle is 45 over 360. You might want to simplify that fraction just now if you're happy doing that. I'm going to cross multiply first. So I have area equals 45 over 360 times pi times 20 squared. Okay, so let's simplify this fraction. Really handy to know what 45 degrees is. I know that 2 45s make 90 and 4 90s make 360, so 4 lots of 2 makes 8. What you don't write is 8 though. This is 1/8. A common mistake is people would write 8. So it's 1/8. If you're really struggling, please remember you can just simplify good old fashioned. Oh, I can see the 9 times table there. 9 times table would make that 5 out of 40. Oh, wait a minute, 5 times table, you'd still get down to 1 out of 8 that way. So we have 1 over 8 times 3.14 times. Now 20 times 20, let's write it out at the side. Remember the old trick, you do 2 times 2, add on the 2 zeros, so that is 400. As always, the fraction always goes into that end number. An eighth of 400 is 50. So I've got 3.14 times 50 to go work out. Let's create a wee bit of space. So to multiply 3.14 by 50, we're going to times it by 10 first of all. And we're going to do 31.4 times 5. Again, it should be a really simple sum you're doing at the end here. No division, no long multiplication. It's just something simple. So 5 times 4 is 20. 5 ones are 5, add 2 is 7. 5 threes are 15. So we get an answer of 157 centimetres squared for that one. Alright. Now, that's me going over area. It is sometimes incorporated into some tricky past paper questions where it's maybe the area of a triangle involved in it as well. So it's worth watching out for them and having a go. Thanks very much for watching. Hope this has helped.